Pile foundations are long, slender members, sometimes also referred to as deep foundations, which are used to transfer loads from above to suitable ground-bearing strata below. An example of where a piled foundation may be used is a building sat on soft soil where a conventional shallow foundation such as a concrete slab would be uneconomical given the required size to achieve a suitable bearing capacity to support the structure above. A piled foundation would be an ideal solution if stronger, more suitable soil layers were located deeper in the ground. Piles resist loading in two ways. Firstly, through shear stress at the interface of the shaft and the ground, which is commonly referred to as skin friction for granular soils and adhesion for cohesive soils. And secondly, through bearing at the base of the pile, known as end bearing. The method of pile installation is an important consideration in both the design and construction phases. Individual piles are installed using specialist plant called piling rigs. Bored piles are installed by first extracting the soil volume in the proposed pile location, and then forming the pile in situ using concrete. Driven piles are instead pre-formed using steel, precast concrete, or timber, and installed in the ground via driving, jacking, or hammering. In Europe and the UK, the design of piles is carried out in accordance with the Eurocode standards. Specifically EN 1997-1 for geotechnical design, with other relevant standards used for structural design such as EN 1992-1 for the design of concrete structures. The Eurocode 7 method requires that pile design must be accompanied by on-site testing. The design of piles must be based upon the results of static load tests for a given site or the calculated design resistance confirmed through validation testing. In the rest of this series, we'll go through some design examples including piles in cohesive and granular soils, driven and bored pile resistance, as well as design combinations to Eurocode 7.